As much as possible I wanted to use things that I already had on hand, so this project box was about the right size, and so I also had the stop and the on-off switch and the RPM meter and Hall effect sensor left over from another project. I had to mount the button and switch a little closer than I wanted to, but that's because of the internal structure of the box. I managed to get hold of this mechanical momentary switch box off eBay from China for very little money, so I'm going to make a control pendant out of that. I did have to buy the multi-core flex new off eBay again, but the wiring is very simple. When I was designing the circuit, I originally intended for just 2 contactors to control everything, but as you'll see in a bit, I had to make some additions to make everything work properly. I found pretty early on that the RPM meter was going to project too far into the box, so I had to cut this piece of polycarbonate as a sort of spacer so that the meter could stand out of the box a bit better. The meter and Hall effect sensor run on 12 volts, so I found an old power brick from a disused piece of equipment and took the circuit board out of the casing, and it just fits nicely down the side there. Luckily for me, with the contactors positioned just right on the rail, the switch and the emergency stop button just about cleared the sides of them. This was the circuit that I designed with the additions because I found out that I needed 2 more relays, these relays, to make everything isolate properly. Now, to mount the control pendant, I decided to use this gooseneck microphone stand and mounted the plate in place of the Dewhurst switch and tapped out the end of the gooseneck mount to accept a countersunk screw which I had in my leftovers box. It was just the right size. Once that was tapped out, I could then mount the gooseneck on the base plate. I didn't want to trust the plastic box to be strong enough, so I cut and drilled this piece of sheet steel just to mount the plastic pendant too. And with that plate mounted to the gooseneck, I could then mount the plastic box to that plate and be fairly certain that it wasn't going to break off. I did want it to stand up fairly high on the machine because I found that the Dewhurst switch was getting full of chips when I was doing milling operations. From the same piece of sheet steel, I made this mounting bracket for the actual control box that can hang on the wall, and just drilled 2 slotted holes at the top so that I could lift the box on and off without having to open the box itself. When I drilled the hole for the Hall effect sensor, I found that the hole wasn't perpendicular to the casting inside, so I made this little brass insert which was a slip fit for the Hall effect sensor and allowed me to adjust it in and out to the correct distance from the spindle. Then just use some 2-part epoxy to glue the magnet for the Hall effect sensor to that unused part of the spindle, and I can always pull it off if I ever need to take the spindle out again. And here's the final setup. Everything's now push button control, and I can safely isolate the machine, and the pendant is well out of the way, so I don't have any danger of catching my sleeves on anything because I'm reaching to switch things on and off. Now I can easily see what my spindle speeds are without having to break out the calculator, and it works fine in either forward or reverse.